Hi there, my name is Anar and I'm the computer science student at the UVic, and right now it's 3rd of November and in 7 days I will have my midterm for CSC 106, and I thought it is really good idea just to go through the main topics that will appear on the midterm, so that I'm as prepared for the exam as possible. So one of the major topics that we will definitely have is binary to decimal and decimal to binary conversion. So I just want to go through that with you guys. So let's say we have number 13 and we want to convert it to unsigned binary. Well, it's really easy. All we have to do is take this number 13, draw a dividing line, and then divide by 2. So 13 divided by 2 is 6, and then 6 divided by 2 is 3, and 3 divided by 2 is 1. So this, the left hand side is a division side. You just divide by 2. What you do on the right side is kind of interesting. If every time the number is odd, you write 1, and every time the number is even, you write 0. So 3 is odd, so I write 1, and then 1 is odd, I write 1. Then what you have to do is go from the bottom to the top and write it as 1101, and this is the binary unsigned representation of 13. One thing I would like to emphasize is never, and let me say again, never go from top to the bottom. Never write stuff like 1011, because this is just wrong. And I did it many times. My friends did it many times. It's just like you always have this temptation to go from the top to the bottom, because like that's how we are just wired. But don't do it. It's just wrong. And we'll see right now that 1011 is actually just a different number. Okay, so let's change the color because I don't really like red. I like wearing red, but I don't like writing with it. So we have 1011, and we want to convert it to decimal. Well, I do it in a couple of steps. So my step number 1 is just to write 2 on top of every number that is equal 1. Every digit that is equal 1. And then on the bottom, what I do is I start writing the indices, or in other words, the position of the numbers from right to left. So it's 0, position 1, position 2, position 3. If you like the term indices or some other terms, it's totally fine. It doesn't really matter. Then what I do is I bring these numbers on top of 2's so that they will be my powers. So we'll get 2 to the power 3, 2 to the power 1, and then 2 to the power 0. So, and as a result, my answer will be 8 plus 2 plus 1. So the answer is 11. Okay? And as you can see, 1011 is absolutely different number to 13. It's 11. So kind of the order in which you're going to be going here from top to the bottom or bottom to the top is important. You should always go from the bottom to the top. Okay, let's go through 2's complement right now. 2's complement is kind of really easy. I'm not going to spend time explaining what 2's complement is. You can Google that. But just one thing I would like to say is that whenever they will tell you to convert from decimal to 2's complement or 2's complement to decimal, they will always tell you the number of bits. So in this case, we have 5-bit. So 3 in 2's complement is, well, we know that 3 is 1, 1, right? And it's 5-bit, so we just add the zeros to the end. So 0, 0, 0, 1, 1. So this is almost, it's exactly like an unsigned binary. When it comes to -3, this is a bit different. So -3, there is a bit for sign. The first bit is usually the sign bit. So we'll have 1, 0, 0, 1, 1. So 1 is minus, 0 is plus, and yeah, this is a sign bit basically. And then the backwards conversion is really easy as well. All you have to keep in mind is that the first bit is a sign bit, so you write minus. And then you ignore all the zeros that come before 1. So I ignore this 0 right now. I just care about this one. So I have 101, and I know that 101 is 5. Well, you can do it like, okay, like for you guys, I'll do it this way. I'll say 2, 2 plus 2 0, but normally you would know that 1 over 1 is 5, so minus 4 plus 1, and that is, well, that is minus 5. So yeah, that's it, we got it, it's minus 5. And now the last thing that I have to go through is, it's a bit complicated. It's called sign magnitude, and it's not difficult to understand, but just gonna take a couple of steps to get it done. So step number 1 is to ignore minus. Well, we have minus sign, that's great. We'll write it here, but we ignore it. We just take 5 and convert it to binary, so it's 101. Then the second step is we take into account the number of bits, so it's 0, 0, 1, 0, 1. Then we flip the bits, so when we're going to flip this, 1 going to become 0, and 0 will become 1, and 1 will become 0, and then 0 will become 1, and 0 will become 1 again. So we flip them, and step number 3 is we add 1 to the end, so it's 0, 0, 0, 0, 1. So we'll end up with 1, 1, 0, 1, 1. So yeah, that is the answer. Let's try the backwards conversion. So we have 1, 1, 0, 1, 1, and we want to convert it to decimal. Well, the thing to keep in mind is that, okay, this 1 is minus sign. So whatever we're going to get at the end should have minus sign. Now we subtract 1 from the thing, from this number, so we subtract 1. So I just subtract it. So I will get 1, 1, 0, 1, 0. Then I will flip it, so I'll get 0, 0, 1, 0, 1. Then I take this and obviously just convert it to decimal, and it's really easy, it's just 5. And then I bring this sign here, and I will get minus 5. That's it. That's all you need to know about binary to decimal and decimal to binary conversion. Maybe some other stuff that you might you have to read is just what is 2's complement and what is sign magnitude. But beside that, you pretty much know everything, and I'm sure you will do good on midterm on this topic. Thanks for watching, and see you on my next videos.